is about to start. We'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound check, camera check, lights check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause this stream is about to start. Get ready wherever you are, 'cause this stream is about to start. Hello everyone and welcome to day 3 of Advent of Code. With me here is David. Hello.
Hi.
And hello to you watching this. So, day 3. How is the Advent of Code for you so far, David?
It's great. It's really good fun. I think we've come up with some nice solutions. I've learned stuff every single time because we're getting sidetracked and discussing lots of the stuff. And there's been a lot of regular expressions so far. Which is
right. I am surprised by... I thought it was going to be more number related, but it's much more about parsing. Because the number part was like greater than, literally. Or summing things up. So yeah, it's a lot about getting the input in the right shape. Mm-hmm. If they gave us the answer in the input in JSON, the problem would be solved in 30 seconds, right?
Yeah, definitely. 100%.
All right.
Yeah, that's been the interesting part so far. I was going to suggest for today that we do it in Swift, because we're still, I think, in the relatively easy realm of problems. Swift is a language that I know reasonably well. I've done quite a lot of iOS programming, but it's not my strongest language by any means.
Oh, that's perfect, because my suggestion was that you drove today. So It makes sense that we pick a language that you know better. And I know what I want for tomorrow. Tomorrow I want... Should I tease? I guess I will tease. I will say that I want a programming language that is really cool. It is a Brazilian programming language, and you like things from Brazil. So let's leave it at that. But tomorrow I can drive and I can use a programming language that is kind of cool. Anyway.
Cool. I don't think Racket is from Brazil, is it? But
you are correct. Racket is not. Racket is from, well, the United States. It was created by a German person who lives in the United States.
Okay. Well, anyway, it would be cool to do some Racket at some point if you want to relive that language.
I was thinking that this morning. I don't remember all of it, of course, because it has been years since I last touched Racket. But I should be able to get by. We'll see. We'll see.
Okay, cool. Well, do you want to do the problem together, and then I've sent you a link to my editor, so you can do the screen sharing for the...
Okay. Yeah, I have already shared with you a live share link as well, but I will join yours then.
I guess you have Swift set up, so it doesn't matter who does it, but...
Yeah, and we can always do the thing that we did yesterday, which was to copy and paste. No, we live shared into Mark's machine.
Yeah, I've got Swift set up. I tested it before the call, so maybe it's best if we do it.
What is the setup? Is it simply installing Xcode, or is there more to it?
Yeah, pretty much. I think if you've got Xcode installed and that's working, then Swift runs. But like, I don't know. I've written a bit of code which reads from an input text and goes through the lines. So.
Wait, are you bringing code to the party? Do you already have code written?
Like boilerplate for reading a file.
Okay.
So,
well, let's jump in and let's start by saying hello to people. Nod was one, and John and Bo. Good morning, everyone. Thanks for joining us. And well, here is the code that you brought. It's importing Foundation, which, as far as I understand, it's like the standard library, the utilities and that sort of thing, right?
Yep.
And then
we have a file manager with the current directory path, and that's the current directory where you execute the program from. And then there will be an input file. So we are not going to do the thing where we copy and paste the input into the file as a string. And then there is a URL. So you're turning a path into an URL, and then you're trying to form a string from the contents. Oh, so it's not like a file reader. It's the string constructor that can read from a file. And like in JavaScript, or I should say like in Node.js, you have to be specific about the encoding. I really think that the encoding should be by default UTF-8.
Yeah.
How often do you read binary files, right? Well, you do, but not that often.
I'm not sure if the what the default encoding is, to be fair, whether you have to be explicit or not. I don't know if it might have a different constructor. It might be explicit, it might not. Convention over configuration, though, I agree, it's a good principle.
Yeah, and then the input array is just splitting by new line. But it's interesting that they named it, instead of the action split, they named it like the result, the components or the parts of the string separated by a new line. So it's a different way of phrasing it. I find it interesting.
Yeah.
And then looping over. So I guess I will ask for you to enable shell access, and
you just run swift.main.swift, and that should work. If you're in the right directory, which you're not, you have to be in O3.
And then that. All right. Okay. So I think that that's enough, and we can get going with the problem. Day 3.
Cool.
You read it this time. It's always me reading.
Okay. Well, I don't even have it open right now.
Don't you have don't you see my screen through Skype? Did I forget to do that?
Yeah, you forgot to do that.
I always forget to do that. Oh, I did it. I remembered to do it, but then you had to get out of the call and come back in. That's what happened.
Yeah.
Anyway, now you can read it.
You and the elf eventually reach a gondola lift station, which I think I've used before when I've been skiing. Not sure why it's called a gondola. But I guess that's what a gondola looks like. Anyway, he says the gondola lift will take you up to the water source, but this is as far as he can bring you. You go inside. It doesn't take long to find the gondolas, but there seems to be a problem. They're not moving. Yeah. You turn around to see a slightly greasy elf with a wrench and a look of surprise. Sorry, I wasn't expecting anyone. The gondola lift isn't working right now. It'll still be a while before I can fix it. No idea where the elf is from. You offer to help. And the engineer explains that an engine part seems to be missing from the engine, but nobody can figure out which one. If you can add up all the part numbers in the engine schematic, it should be easy to work out which part is missing. The engine schematic, your puzzle input, consists of a visual representation of the engine. There are lots of numbers and symbols you don't really understand, but apparently any number adjacent to a symbol, even diagonally, is a part number and should be included in your sum. Periods, dots do not count as a symbol. All right, let me read that again. There are lots of numbers and symbols you don't really understand, but apparently any number adjacent to a symbol, even diagonally, is a part number and should be included in your sum. Periods do not count as a symbol. Okay, here is an example. So you've got 467 and 114. Okay. So let's look. In the schematic, two numbers are not part numbers because they are not adjacent to a symbol. 114 top right and 58 middle right. So 114 is not adjacent to the symbol. And 58 is also not adjacent to any symbols. But that means that 633 and 467 and 35 and 617, they're all 592, they're all close enough to a symbol that they are considered part number. Their sum is 4361. So I'm going to assume, well, it's all the entire number. It's not just like the 5. It's like as soon as you become part of that block, you become a number. Okay. I'm thinking breadth first search is the first thing which comes to mind, but
Ooh.
yes. We'll see where we go. Every other number is adjacent to a symbol, so is a part number. Their sum is 4361. Of course, the actual engine schematic is much larger. What is the sum of all the parts of the numbers in the engine schematic?
And let's take a look at the puzzle input here to see how big it will be, just out of curiosity. It's okay. It's manageable. With some patience, we could do it by hand even. It's not that large.
Yeah.
But I'm sure that the symbols are going to come into play in the next part. Like the plus is going to be, you should add the next number, and the star is going to be multiply, right?
Of course. But what's the hash going to do? And the dollar? And the at? I don't know. Maybe just like by default they're negative or something.
Who knows?
I don't know. Who knows? Okay, so let me take the small input then and put that in input.txt. So yeah, my first thought is breadth first search.
Tell me more.
But maybe that's overkill, or there's a simpler way of thinking about this problem. But yeah, so my first thought, I mean, I am going to paste this in anyway, just for the example, just so we can look at something. So it's actually annoying that it's not monospace. What is this monospace? Does this really...
It is monospace.
I guess that does occupy the same. It just feels like it isn't. It just feels like the asterisk is bigger. But that's just my... But
well,
yeah, so
also you
like,
see this with a different font on your computer. So there is that.
That's
Maybe for you, the asterisk looks weird. You can see here on Skype, on my screen share, that it looks monospace to me.
No, it is monospace on mine. It's just my eyes are not very good these days. So with breadth first search, I guess I would, if I would probably start with the numbers. Yeah, so I would go from left to right and then keep incrementing the number. I keep going, like, mark all the nodes which I've seen as visited, or the cells, and then keep expanding from that. It could be depth first search as well, I suppose, but breadth first search is easier to think about. And then if I come across an asterisk, then I know that I'm going to use it. And although the only issue with breadth first search is we need to read the numbers like in order. So I kind of want to do it left to right.
It's interesting because you are going from, I will start reading the number and then detect whether I should taking it in account or not. And my first intuition when I read the problem was the exact opposite. I thought of, I'm going to start at all the symbols, and they are easy to find because, regular expression or whatever. Anything that is not a number or a dot, I will get the coordinates for them.
Yeah.
Then I will look at the 8 neighbors, right? You can count the neighbors on the diagonals as well. So you have 8 neighbors.
Yeah.
And then I will check if the 8 neighbors, if they are a number or not, or I should say if they are a digit or not.
Yeah. Yeah.
And then I will, for each of the digits that I see, so for instance, for this asterisk, I would look at the 8 neighbors and I would detect a 7, a 1, a 5, and a 3.
No, you wouldn't detect a 1.
Oh, sorry. Yeah, right. I would not detect
Yeah.
the 1. So I would detect
But
the
anyway, yeah.
7, the 3, and the 5. Then
Yeah.
my next step would be to, I guess, detect the number associated with that digit. So I would detect for the 7, the 4, 6, 7. For the 5, I would detect 35. And for the 3, I would detect 35. I would put these detections in a set because I want to have only one instance of the 35. Then I would rinse and repeat for all the other symbols, accumulating all these numbers in the same set, because if there are two symbols touching the same number, so for instance, if there was a symbol here, I would want the 35 to only be accounted once. And then I would finally add all the numbers in the set. So I would go from symbols to numbers, and you are proposing to go from numbers to symbols. So you would not need to do the deduplication, but you would need to look around to see if there is a symbol, which is perhaps even a simpler approach. So I think I like your idea better, but I think both would work.
Yeah, well, that would both. I think both would work. But just to summarize, number 1, find a symbol. Then number 2, find neighbors, which are digits. Oh, and then how do you? What is the data structure that you're keeping to make sure that you don't? How are you like then reading the numbers? Are you just because you
I
might have
would-
to read back?
Yeah, I would store in a set the coordinate and the number itself. The number itself, it will be necessary for summing in the end, but I need the coordinates to deduplicate because maybe there will be two 35s in the grid and they need to be different.
Yeah, and then part 4 would be store. How would you read the numbers in there? And
Oh,
once
for
you've got-
instance, if I detect that I need to, I detect that this digit is relevant, I would just go left and right of it until I reach a dot, end of line, another symbol, what have you, until I reach a non-digit. And then I would get the coordinate of the number.
So iterate left and right from each coordinate. And then I guess it would be like maybe a map from like coordinate to like number, because there can only be one number per coordinate, right?
Yeah, no, I was thinking of the coordinate more as a like the identity of that number. Because, like I said, there could be two 35s in the grid, and I just want to know that
Yeah.
they are different. So I would store, for instance, for this guy, I would store 35. I guess what I'm saying is I don't think of this as a map. I think of this as a tuple, in which the 35 is what I really care about, but I also tack on the
Yeah.
coordinate of the 35 to differentiate it. So in this case, if we are starting from 0, it would be the coordinate 1, 2, 1, 2. So it would be coordinate 2, 2.
Yeah. Okay, that makes sense. Yeah, that makes sense. That makes sense. So that kind of thing. Okay. And then to briefly go through what I was proposing.
And I'm going to
I
write
would-
this down just to make sure that people understand what I mean here. So I want a
Yeah.
set of tuples that contain coordinates and numbers.
Okay. I think let's briefly go through my proposal.
Which
and
I think is
then-
better, and I want to do yours, but
Okay, all right, cool. We can also put it to the chat. Maybe they have some opinions. Or if they, yeah. So mine would be iterate through like just through the 2D array. Encounter a number. Because I'm going left to right, I can it will be trivial to keep reading the number, right? Read the entire number. Then step 3. Hmm.
Well, I guess step 3 is look at all the neighbors of all the digits, right? So if you encounter, for instance, the
Yeah.
number 35, then for the number 3, you will have to check all the 8 neighbors. Is one of the neighbors a symbol? If so, I will put it in the set. Or in your case, it can even be a list, or you can even compute the sum as you go.
Yeah, I'm just wondering if I read the entire number or I do that afterwards.
I see.
I guess yeah, I could read the entire number and then I would check if I should keep the number. Check neighbors of each digit, kind of thing. If that makes sense. And then that way I don't need to worry about deduplication because I'm reading left to right. We might come unstuck in the second part of this, but I think this is relatively simple.
Yeah, I like
do you
yours
think?
better.
All
Let's see if chat wants to have opinions. John says, I think first looking for number and then look if there is a symbol near makes the coordinates thing unnecessary. It is easier to collect numbers. Yes, so chat agrees with me that your approach is better than mine.
All right, sounds like a plan then. So first we have to parse this into a 2D array. I'm going to call it a board, which is an array of characters, I guess. And then oh, have I got 4 spaces? Well, that's fine, I suppose. Let's print this out, see if this worked.
Yep.
Yeah, that looks all right. It's annoying that it's not very pretty how it's been printed. I don't know if there's an easy way to pretty print in Swift. I'm sure there is. Pretty? I don't know. We'll get to that.
I feel like a robot is involved.
Well, a robot's involved anyway, because if you Google it, then you're still like relying on a robot to surface it. So, okay, now we've got the board, we need to do the first part, iterate through the 2D array. Let me just delete this for now. Do I want to do this? I'm going to say R in... I'll just take that in a loop. Yeah, let char.
I have a question about Swift syntax. What is this less than sign?
I think it's a range, right? From 0 to less than that count.
So the less than is indicating that the range is non-inclusive?
Yeah.
Interesting.
So
and if you wanted the range to be inclusive, you would do ... Okay.
Yeah.
That's new to me.
Interesting, yeah. You're still forming an opinion on whether you like it?
No, I don't like or dislike it. It's just now I understand it.
So if it's a number,
there is a isNumber attribute, let's call it, on the character. That's cool.
yeah, I guess that is useful. I'm thinking we'll have a current number like this,
Hmm.
and we'll keep appending to it
Mm-hmm.
like that. And then if it's not a number, then we need to check if we can keep. We need to reset the current number to that, and then if can keep number. I can't think of a better idea right now. Yeah, so what we actually need to keep is we're going to need to keep the current number and the row and the column of the initial one. So it will be row, but then we just need to do column like minus whatever. The current number.count, so that we can start iterating, if you see what I mean.
I don't really understand what you're going for here with this. It's an auxiliary function, right?
Yeah, I'm going to implement this separately.
Yeah, okay. I guess I will need to see the whole picture to make sense of it. So carry
But
on.
the idea is that we're going through the board, and then we keep accumulating this number, and then as soon as we hit the end of the line, we also need to do this at the end of the line actually.
Mhm.
If there's I don't like that there's 2 times that we have to call this, but it is what it is. We're going to check if the number that we've accumulated is close enough to a neighbor, basically.
Why don't you do this as you go? Because you are iterating through the characters anyway. How about while you're iterating and you are accumulating the current number here, why don't you just, while you're doing that, check the neighbors and keep a variable? Like, to begin with, the can keep number or should keep number is false.
Yeah.
And as you're iterating, you're looking around, and if you find something like an asterisk, then you change that variable to should keep number equals true. And in the end, when you reach the end of the line, or when you reach a character that is not a number, then you already have your current number in a variable, and you know if you
let's
should
do
use
that.
it or not.
Or has symbol neighbor, maybe?
Can I make... I'm going to get my crystal ball here. I think that the different symbols will have some significance, so don't have a has symbol neighbor, but a get symbol neighbor, if you know what I mean.
Okay, yeah, that's fair. Not equal to nil then for now.
Mm-hmm.
And then we still need to do this. So yeah, if should keep number, I'm going to numbers. I don't know. Don't have a. Let's make this an int though. If we should keep the number, then we will append the number, reset that to false, and then we also need to do this at the end. Does that make sense? The only thing to implement is get symbol neighbor, obviously, which I swear I'm spelling neighbor correctly. Is this the isn't the American spelling that?
Correct. And it was you also wrote something else in the British spelling, but maybe it's something that you already removed. Anyway, carry on.
It was neighbor, and I added it to my user dictionary a second ago, and then but then I thought it would have worked anyway. But yeah, so let's just double check this logic before we implement get symbol neighbor. So we if it's a number, then we keep accumulating it. Otherwise, we need to reset. If we have a number, probably. Oh no, if we should keep the number, then we can append it. Otherwise, we just reset everything, and then we also need to reset it at the end here. I don't like this thing where we like do it. You know, we have we do this in two places, like this block here, and this block here, and this block here. How do I? Is it Alt? Yeah, it's Alt. But anyway, yeah, these two here. It's kind of like duplicated code. I wish it could somehow simplify this. I guess I could do it by iterating to make this non-inclusive would be one way, and then just like skipping the last character. But I don't know. I can't think of anything right now.
Yeah, I'm first trying to ascertain if I agree with what is on the screen. If I think that what is on the screen is correct, and then I will try and make it better. And wow, it's growing fast.
So neighbors, does this look right? So we do need the diagonals. So this is...
That's top left, then this is middle top, this is top right, this is left, this is right, this is bottom left, bottom middle, bottom right. Yeah, the coordinates look right to me.
In fact... do I want to do it this way?
You see, I have CSS ingrained in me. I would always look at it as north, northeast, east, southeast, south, southwest, west, north, west.
Yeah, this does look all right though.
Yeah.
Okay, and then it's the kind of thing that Copilot's good at anyway. So then we do need to check the out of bounds things here. So, and we also need to iterate through the word. So this is, oh no, this is fine. Yeah, we just need to iterate through. We also, yeah, that's fine.
Yeah, there is another thing that I want to check real quick with the real input. Is there a case in which a number is adjacent to two symbols? Because then it would not be get symbol, but get symbols, if you know what I mean. But apparently not. I'm looking at the inputs here, and there is always at most one symbol adjacent to each number. And there may be two numbers adjacent to the same symbol, but there are never two symbols adjacent to the same number. So I am pretty sure that the symbols are going to be different operations. We are not just going to add, we are going to do something. I'm pretty sure part 2 is going to be a piece of cake. Mark my words.
So I'm going to delete this code and do neighbor in neighbors. And then I'll start this as row and... Oh, there's a way of doing this. I think it's like this. And then what we need to do is add this to the row and the column, right?
What's up with that? What is this syntax?
So this is renaming it. I can't remember which way round it is. It might be this way round. So there's like the external name and then the internal name. Which is super useful, actually.
Yeah, no, I can see that. And I do that in JavaScript as well, because you can do the structuring assignment and rename the object fields on the go. But my question is, why do you want internal and external names to be different?
Because we've got these row columns here, and it was just sort of like confusing the two of them.
And is there, well, in Swift, are all the arguments named?
Yeah.
I see. Okay.
Unless you can do like this, and if you do that, then it's not named, and you can just call it with the first argument not named.
But the arguments are not positional; they are always named arguments.
No, they are positional as well. So you can do like this. and then you don't need to name them as you send them in.
Oh, and now I want to see the call to this. Oh, yeah, right. You had to name it like this. Is there any shorthand for when your variable is the same as the field name?
No, that you have to define that on the. As far as I know, anyway, you'd have to define it like that, and then you don't need to do that.
And if I reorder this, will it work the same because it's going by name?
No, I don't think so. It will say like you've done it in the wrong order.
Ah, so it's positional and named. That's weird. Okay. Anyway,
it's very precise. Yeah. So we need a name for the shifted, I guess let neighbor r. Yeah, that'll be fine. Oh wait, it's done it. It's done it all. It's added it already. I was gonna think these were all just -1 and whatever. We actually don't need it like that. It was probably fine already. Yeah.
that looks about right to me. So let's
Yeah.
see. You want it to be if less than 0 or greater than count, or less than C or greater than the count of one of rows. Continue. And in other words, bail out. And then we are getting the character and we are checking specific characters. I don't want to do that. I want to see if it's not a number and it's not a dot. I will go ahead and do that. I will drive for a
Sure.
sec. Because we learned that there is a thing as like
digit.
is number.
It was digit, I think it was, wasn't it? Well, no, you're right. It's his number.
So
Sorry, my
if
bad.
it is not number and it is not a character that is a dot, then return it.
Yep.
And did I get my negations, my equalities, all of that, my and? Did I get all that right?
Double negatives. Yeah. Yeah.
Okay.
And then I guess we want to just print the numbers that we got.
Well, add them up.
Yeah, that's true. I mean, we can probably get rid of numbers if we do it this way, but
We can. I will be doing that while you're doing your thing.
Okay.
It just keeps coming back. What's up with that?
I don't know. I guess it's like
The live
they
share.
don't have a, yeah.
All right.
4361 is our answer. Should we try that? I mean, I have to try that actually, because it's not the same puzzle input as you.
Well, 4361 is the right answer.
For you. Oh yeah, sorry. Oh yeah, sorry. This is the test. We haven't done the puzzle input.
But anyway,
You can paste your puzzle input into.
I am curious because it also printed the board. We don't have a print for the board anymore. Oh, we do. Okay.
Yeah.
So that's your answer.
That's my answer. Do you want to try yours?
I will
Is that
try
cool?
mine as well because I mean, we are here. I want to get my stars.
You gave an answer too recently. You have to wait another 27 seconds because I pasted the test answer in by mistake.
Well, that is the right answer, David. Woohoo!
Woohoo! Okay,
Good job. Good job.
Nice.
And Jack is here. Hey, nice to see you. The problem with speed code is truly horrible code for a normal work session. Beginners have to know that is not the way to write code for a job. Yeah, and in our case, we are not really interested in speeding. We are not interested in getting on the leaderboards or anything like that. But I do think that our approach is somewhat reasonable for work, for a job, as in we are trying to get it right then we will try to make it better. For instance, Dave is not too happy that he had to copy and paste his snippet of code. So we could look into that and see if there is a better approach. And so we are cutting some corners, but not terribly. We are not trying to golf the code, is what I'm saying. But anyway.
But even so, I mean, even something which is totally impractical, like code golf, I think there is an argument that just it's a similar skill set in a way, and just the number of hours. I think it stands to reason that there'll be a very high correlation between good engineers and code golfers, even if like the skills aren't very well aligned. Just the fact that you're so interested in that kind of thing, I think it might just influence you in other ways.
I think that if you are a really code golfer, it can go one of two ways. The first is you learn all the quirks of the language, so you know to avoid them because they are too clever and they're gonna trip people up. And when it's absolutely necessary, you will be the person who knows that that's a possibility, but that should be rare. Or it can go the second way, which I have seen happening because I have done it myself, where you're like, oh, I know all these quirks, I know all these things, I'll just use them because they are cool. And then everyone looks at your code and is like, what? So as long as you're disciplined about it and you know that you're not supposed to make everything into a puzzle, you should be fine.
Yeah.
Do you want to continue to part 2?
Let's do it. Oh, actually, let me try and submit my. I want to get my gold star.
Get your gold star.
I got it.
Yay! All right, part 2.
Do you want to read?
No, you read it.
Okay. The engineer finds the missing part and installs it in the engine. As the engine springs to life, you jump in the closest gondola, finally ready to ascend to the water source. I feel like I'm reading to my niece. You don't seem to be going very fast, though. Maybe something is still wrong. Fortunately, the gondola has a phone labeled help, so you pick it up and the engineer answers. Before you can explain the situation, she suggests that you look out the window. There stands the engineer, holding a phone in one hand and waving with the other. You're going so slowly that you haven't even left the station. You exit the gondola. The missing part wasn't the only issue. One of the gears in the engine is wrong. A gear is any star symbol, hey, you're right, that is adjacent to exactly 2 part numbers. Its gear ratio is the result of multiplying those 2 numbers together. This time, you need to find the gear ratio for every gear and add them all up, so that the engineer can figure out which gear needs to be replaced. Consider this the same engine schematic. Consider the same engine schematic again. In the schematic, there are 2 gears. The first is in the top left. It has numbers 4, 6, 7, and 35. So its gear ratio is 16345. Multiplying them together, I guess. The second gear is the lower right. Its gear ratio is 415490. It's 617 multiplied.
Wait, what?
By itself. The lower right.
The second gear is on the lower right. So I suppose it's this.
Yeah. The star adjacent to 617 is not a gear. Because it's only adjacent to one partner. So there's 1617 in the middle. So the 755 times 598. I mean, we can verify that, but is the 451490.
Mm-hmm.
But then the 617 is on its own, so it's not a gear. So it has to be a pair, basically. What if it's 3?
There will not be such a case, I don't think. And okay. I will just say it, if we had done my approach, this would have been even easier because we would have a symbol and all its neighbors.
Yeah. Yeah, 100%.
And now we have to piece things together. We will need to not only get the symbols, because now we need to see if it's a multiplication sign. If it's anything else, we will ignore, right? A plus, anything that is not a multiplication sign, we will ignore now. But now we will need to not only get the symbol, but we will need to get its coordinates, because we will need to do the matchmaking between 4, 6, 7, and 35.
Yeah.
Or we can just
Yeah.
turn the whole thing on its head and do my approach, which is not terribly difficult too.
Yeah, that's also possible. And also, my initial thought was to do sort of a hybrid where we do actually a breadth first search when we hit a number.
So you are going to not only look at the 4, 6, 7 and detect that you want to collect it because you see a star, but once you see the star, you will look at the star's neighbors and be like, okay, is there any number around? Oh, there is a 35. All right, so that I'll do the multiplication right away. And then you have to keep track that you have already multiplied this so that you don't do it again. In
Yeah.
other words, you want to do it from left to right, top, bottom. So when you're looking at the neighbors of the star, you only look right and down. You don't look left,
Yeah.
or you would see yourself again.
Yeah, so my initial thought was like, find the number, right? So reading from left to right. Okay, I found a number. Now iterate through all those digits and go breadth first search to see if I can find any symbols. If I find, and then keep expanding away. But I think that I basically would have to keep track of a separate array of all the elements that I've already visited.
No,
that when
not really, because when you're doing the traversal from left to right, top down, you will only find stars to your right or to your bottom, because you have
Yeah.
already visited stuff, so you'll not find stars above you.
That's true. But what about when I move to the next line and start looking for?
Well, if
Like-
if the star was relevant to your gear, you would have already seen it when you visited the thing above. You would never get to the 35 without having seen the 4, 6, 7 before. So the trick is, we are doing our thing, we are looking at the neighbors, we find a star. Bam, we found a star. Now we want to see, is this a lone number, or will there be another number that I need to multiply by, right? And you can do that by looking at the star's neighbors, but you don't look at the neighbors on all 8 coordinates. You only look at them, I want to say, to the right and
Southeasterly.
below. Yeah, so you only look, you forget this, you forget that, but you do look at these neighbors that I'm highlighting now.
The one above as well?
And I think that this one as well. Yeah, this one. But this you don't look at, because if this was a number, then it would have been part of this number. And if this was a number, then it would have been part of this number. So you don't look at this, but you do look at that. And you also look at this guy, because there may be 2 numbers in subsequent lines. So just by virtue of doing the neighbor check for the star in this more principled way, you don't have to care about the duplication, because you see them in order as they appear. Fairly certain that this holds.
But when you go to the next line, so like, say you find 4, 6, 7, and 35, you're still going to have to continue to 114, right?
Uh-huh.
To check if there's more stuff.
Yes.
And then you could reach the end of that line, then you go to the next line. You may not have checked everything. Wait, is all we care about gears?
Yeah. We don't care about these symbols anymore.
Yeah, so we will have to go to line 2, right? Which only has stars as well.
Yeah, when you see a star, you ignore it, because you're only looking at stars that are adjacent to numbers, right?
Yeah.
Otherwise, you start implementing my approach.
Yes, but what I'm saying is, then we will go to the third line eventually, right?
Mm-hmm.
And then how will we know not to look at 35?
Well,
I
because
guess.
we will look at the 35 and we will see, oh, there is a star that is a neighbor, but it's at the top. Okay, I have already seen it. If it was relevant, I would have taken care of it because of its other neighbor. The stars that are above you or that are to your left don't count.
Okay. And then, so we'll just ignore 35 because we'll look for its neighbors and we won't find anything. Okay. But it's going to be a little bit tricky, isn't it, to implement that little like breadth first search inside. Because when you hit the number, then you have to sort of keep checking for all the stars, and then if you find a star, you're like, okay, now I need to go another level deep and accumulate the other gear, right?
True. And
Which is a
even
little...
when you're doing the star thing, you may get to the number 5, and then you have to do the thing of going to the left and going to the right to piece together the 35.
Yeah. Okay.
Do you want to do
So-
this or do you want to do the other? Do you now that you have seen the full picture here, are you more inclined to just grab 4 stars and then look at their neighbors, piece together the whole numbers, and multiply them?
Yeah. Yeah, I think so.
Oh, Theo is here. Hello, Theo. It's great to see you.
Hi, Tail. Yeah. Yeah, I'm a bit more inclined to do that. Should we do that?
I wonder if. No. I was gonna say, I wonder if the same number can be part of 2 gears, but we have already looked at the inputs and it doesn't seem like that's the case. We never have 2 symbols adjacent to the same number. So, yeah. Wait. I saw this and I was like, wait, there are fractional numbers? No, a dot is a separator. So, yeah, I guess with that we are ready to get going. I think we have a fair idea of what we want to do.
What, for the first one or the second one? Which implementation?
Well, I am inclined to search for stars, look at neighbors, and multiply them.
Okay, let's do that.
I
I'm going
think
to duplicate this file
Okay.
and call it part 1, and then we can delete this code.
And you also have main.py and main.ts. Were you considering using these languages?
Well, actually, I was starting to make like a template function, a template directory, so that I can just duplicate the directory, and then I can, do it accordingly. So we still need this. We still need the board. So to repeat, the strategy is, in fact, if I just go back, we have the strategy somewhere. Oh no, it doesn't keep the memory. Okay, fine. Find all the positions of stars. Then for each star, find numbers, I guess, above and below. Are we going to need to deduplicate?
Well, we do, because they may not be above and below. For instance, I saw a case in which they were side by side, like so.
Yeah. Yeah, okay, fine.
So we just need to find numbers around, and I guess one straightforward way of deduplicating was my idea of keeping the coordinate in a tuple.
Yeah. Or just can't we just do it in order?
Hmm.
Or would- I'm not sure. Because we only need to do that deduplication per star, don't we?
Correct.
Or is it possible?
It's only per star because we have determined that no number will be neighboring 2 stars. No number is
Yeah.
part of 2 gears.
Yeah. Okay, well, I guess we'll get to find surrounding numbers later. So for now, we can just do... Oh, I'm modifying part1.swift. That's annoying. Let's call this part1.swift, and then I can copy this into main, and then I can delete this. And then... and then I can take this, because this was useful. Okay. So if the... Okay. If it's equal to a star, yeah, those are the neighbors. Fine.
And this time we want to look at all of them, not just the ones on the right or the bottom, like I was saying before. Yeah.
And yeah. So we need to accumulate the numbers now.
Yeah, it is a matter of going to the left of your column and iterating until you find a known digit or the end of the line, accumulating that on the string, then doing the same to the right hand side, accumulating that on the string, and then finally converting this string into a number.
Mm-hmm. I'm just trying to work out how to do this deduplication thing. So we can... So your thinking was to append the coordinates into a set of each char, of each neighbor? Is that right?
I was planning on creating a set containing numbers and their coordinates.
That's not what I want. I don't know that this is going to work in terms of typing. Can't remember how to do that.
Is there such a thing as a tuple in Swift?
Yeah.
Okay.
Yeah, there is. Let's see if we can do this. Yeah, that looks right.
The coordinate looks right. The character doesn't. I want the number, not the character. I want a number.
So this will be a string, yeah.
No. It's going to be literally a number. At that point, when we have pieced together the number, we might as well just convert it into an integer, right? Not that it matters
Yeah.
much.
Yeah, that makes sense.
And it's cute that the notation for set is square brackets, which I would associate with a list, not a set.
That is strange, actually, because that is, I mean, that is also how you do lists.
Is it going to be like, oh, I see that it's actually the type is a set, so I'll do the conversion for you?
I think it might, yeah.
Okay.
So, the set of numbers and coordinates. Okay, so I think we can just append the...
Can
Do we
I
want
can
to
I
append-
drive this part?
Yeah, go ahead, go ahead.
Okay, so what I want to do is I want to create a string that I'm going to modify. So I'm going to create a var of my, I'm going to call it the number string, which I'm going to start with maybe this character. How about that? No, this is the star. No, this is the number. This is a number. I'm already looking at the neighbors. Yes, so I'm already looking at the neighbors. So this is my character. Then I'm going to go first to the right. I'm going to go first to the right because I want my coordinate to be the top left. So I want to do left later. Oh, I'm still following your cursor. Okay, then... Oh, and only if the character is a number that I want to do that. Now I want to, or maybe a while loop. Yes. While I will have my number column while it is less than the size of the board, and the character that I find is a number, I will concatenate my digit that I have just found. And judging by this squiggly here, it wants me to do this, which I will. And I will format this by hand. How about that? So I have seen my number, and I have gone to the right of it.
You need to increment the number C.
Ah, yeah.
So I guess because you're going right, you don't need to worry about going left because you're always going to visit left first.
Well,
need
what
to
if I started
check.
in the middle of the number?
Yeah. So maybe you do.
Right? Now I want to go to my left.
And prepend it to the number string.
Mm-hmm. So while my number C is greater than or equal to 0, and my, I should look at the coordinate number C here, or I'm setting myself up for an infinite loop.
Yeah. That
Then
makes sense.
I will be concatenating, but to my left this time, and I will be subtracting this time, and I also want to reset like so. And when I get there, at this point, I can add to my set, which is this set. So I wonder how I add to a set. Is it something like this?
Does it give you autocomplete? Yeah.
It does not give me anything when I say dot.
Huh. What about on my end? Yeah, also not giving me stuff. Normally use Xcode for Swift, to be fair. It's not the best. You can set it up, but I haven't got it set up right now for VS Code.
So do you want to do the Copilot thing and ask how to add to set?
Yeah, it says insert.
Okay. And then what am I adding? I am adding the integer version of number to string, and I wonder what that is about. And
That means it forces it, because if it's like it will the program will crash if it's not actually a number.
so the type system is saying maybe this will crash, and you're saying no, it won't.
So the type system is saying like, yeah, it could be nil. And you basically say if it's not nil, then crash the entire program.
So this is not only, for instance, in TypeScript, we have a similar thing to silence the type system.
Yeah.
But in this case, it's a runtime check.
Yeah, so yes, it's a runtime check. But also I don't like this being like a crashing the entire program. And also TypeScript is like the exclamation in TypeScript is like, I know what I'm doing. Like it's almost like a TS ignore. It's almost like TypeScript, just ignore this, I know what I'm doing. Whereas this is like, but it could be like liable to runtime issues, you don't know. And if the things change, it could be like, could break in the future. Whereas this is, yeah, a runtime check, but it crashes the entire computer. I wish that it would instead, at least in TypeScript, just throw an error. Like you had an assertion, this part of this function threw an error specifically that it tried to assert that this
wanted to be able to catch this, and so that it was throwing an exception instead of crashing. That makes sense.
And I was thinking of making a Babel transform rule for that, for TypeScript.
Wait, what? Babel? Is Babel a thing in Swift?
No, I wouldn't do it for Swift, I'd do it for TypeScript. Because in TypeScript, I think it should do that.
You wanted a runtime check when you use the exclamation mark in TypeScript.
Yeah, exactly. Yeah. And to throw an error in that would be super useful, I think. Because I do a lot of like in TypeScript, I'm like, assert this and then throw an error if that didn't happen.
Well, you know that what you want to do is violating one of the tenets of TypeScript, in the sense that, of course, you are welcome to do it, but it's something that will never make it into the language, right?
Yeah, because it's meant to just be comments, basically.
Yeah, you're never supposed to change the semantics of the program when annotating, and this is essentially a type annotation. Anyhow, so we need to revisit this because there are mistakes here. Particularly,
the deduplication.
There is one character that is being inserted twice. So
also
I guess the solution is to do this. Let me convince myself that I think this is the right move. This is not the right move, because then we may get out of the board, and then this, when we add it here, will be wrong. I know you just changed it, but no, this needs to be the coordinate of the top left of the number.
Okay, yeah. That's true, rather than the starting coordinate, yeah.
And this needs to be +1. There, I think that does it.
Why does it need to be +1?
Because the condition that makes us stop this while loop is that we have gone over, either because we have gone out of the board or because we found something that is not a number. So it means that we have overshoot with number C, so now it's time to add one back up to get us back into the number. Not that it matters too much, because the point is that this is only used to deduplicate. So we could say that number C is... it amounts to the same, but I think it's more proper if I put it the +1 there. Okay.
Yeah, that makes sense. That's a good reason for going a neater way of doing go right and then left as well.
Yeah, which again doesn't really matter. If we had gone left and then right, then the coordinate would be the top right of the number, and then that's, as long as it's systemic for all numbers, it's going to deduplicate all the same. So now we have this set. after we have seen all the neighbors, we need to check the size of the set. If the size of the set is 2, then we want to get the numbers out, multiply them, and add to our running sum. So there is the set of numbers and coordinates, and I want to check its size. How did I do?
I think it's count. I think generally it's count, and it's not a function.
Ah, okay. Okay, so if
Parens aren't needed, by the way.
are they optional or are they not allowed?
I think they are. I think they are optional because you can just put things in parens so that they just generally parens are. You can use them in math expressions and ternaries and whatever. So you probably can put them in there. It won't make a difference, but it's unconventional.
Okay. So if the set has 2 elements, then we need to get the elements out of there. And you can do that by turning the set into a list. You can do that by just iterating over all the elements. I'm going to iterate over all the elements because it seems easier to me. So I will call this a gear, and it's going to start as 1. And then for, has no parentheses, for number and coordinate of, I'm writing JavaScript here. How do I say that? How do I iterate over a set?
In instead of.
Great.
Yep.
And is there the structuring assignment?
There is. Yep.
All right. So
fact,
I'll do this.
We did it on line 48.
Excellent. And then I don't really care about the second one. And
Nice.
then I will multiply the number here. By the end, I will have my gear sum.
Oh, you don't want to do it.
There.
You don't want to. Yeah.
And then I need to start my gear sum at the top. And then I want to print my gear sum at the end. Yay, I wrote some Swift.
Nice.
I wonder if it's correct.
The only thing I just need to work through in my head is that we won't hit the same. The same thing twice. Guess we only hit the star once,
Yeah.
and therefore, because it can't be a part of multiple. It's never threes, because it's only ever pairs. If that's true, then we're fine.
There is a
Because
problem. There is a problem. The problem is, look at, for instance, this case. We are going to be looking at our neighbors, and then we are going to find, okay, I found a 7. Oh, great. I will get my 7. Okay, and then I move on, and then I find a 5. And then, okay, I will get my 5. No. That's what the set is doing. It's deduplicating that way. Okay. Yeah, never mind me. I was going to say we are going to account for 35 twice, but we won't. That's what the set was for.
Yes. Yeah.
Well, here is another problem. We are putting this number string, we are putting the character here, but then we are doing the number C plus 1 here. So we are putting the character in the string twice.
Ah,
Yeah. What else?
good catch.
Yeah, I want to run this.
Okay, let's run it. I don't know whose input it is right now.
Right. Right now it is my full input, but let's put the test input here real quick. Did you know that you can triple click in Advent of Code to get a whole block of code?
Can't you do that in any like code block, or is it just?
Good question. Let's
I
go
think you can do-
to...
Like if you click on any paragraph, it does that in Advent of Code.
Yeah, it does that to paragraphs, even in other websites. But
Yeah, exactly.
I wonder if that works in like any snippet of code anywhere. 1, 2, 3. No, it doesn't work everywhere. It depends on how you do your
Yeah.
snippet of code. It's not a browser
Better work
feature.
on paragraphs.
Yeah.
Okay.
Okay. So with that, we are ready to run here, and we have a compiler error. The error reads, failed to produce diagnostic for expression. Please submit a bug report and include the project. Great. It means that we have hit a compiler
Found
bug that Apple doesn't know about. And look at that. It's huge and it's scary.
It is huge and scary.
Yeah.
And we found a bug in Swift on our first day. Wow.
Yeah, not bad, not bad.
Does not conform to hashable is the thing. It's the set of numbers and coordinates. It's that construction.
So apparently Swift doesn't know how to deduplicate tuples like that, which is surprising to me because integers are probably the simplest thing to deduplicate, and tuples of integers are probably the next thing. Even
Yeah.
strings are harder.
I mean, it should know how to deduplicate structs quite easily.
Okay. Can you do that transformation for us?
Yeah, sure. Let's try that.
Do we want to report the bug to Apple?
Let's try that. And yeah, because it conforms to hashable, this should work.
Wait,
And,
could we just say hashable and then the tuple?
Yeah, maybe. How would you do that?
Well, I would put a comment saying, make this tuple hashable.
Okay. Okay. Let's try that. Let's try. That's what it's coming up with.
Nah, I've seen that before, Copilot.
No, that's slightly different. But
But we are not alone here. Let's see if people in the chat know the answer to this. Aw. Tail, you don't
Well,
know
maybe this is-
Swift?
make tuple hashable. I'm just googling it. Maybe you should Google it though.
Oh, you're Googling for this.
Yeah.
Do you want to try and just do the hashable struct?
We could definitely do that.
Okay. I'll let you figure this one out as the Swift expert in the room.
Oh yes. Okay. it looks complicated to extend, make them hashable. So I'm pretty sure this will work with. Where was the? Yeah. So hopefully it's still in my. Okay, that'll do. It's a bit weird to define it in line like that, so I'll just do that. And then number of coordinates, and then so I'll just keep that. Okay,
Cute.
that looks decent.
And then this structuring needs to change as well, I hope. I suppose.
Oh yeah, of course.
I expect.
Yeah. Probably there's a way of making it so that it was destructurable, but
I will change this variable name.
yes.
And with that, we can run again. I
Okay.
am pressing buttons here to run things. Okay, different error this time. It's not telling us to contact Apple anymore. So I guess that's good news. And geez, the error messages are scary. Wow.
They are, aren't they? They're much better in Xcode.
Okay. The type,
Wait, hold
number,
on.
and coordinates does not conform to the protocol hashable.
But it does conform to protocol hashable. Oh, stored property int does not conform to hashable. That's the
The coordinate. Spell
Yeah.
out the coordinate. X and Y.
so should we just do row and column?
Yeah.
So this should be. Oh, no, it's not remembering. Okay.
That's all.
Another error? Oh, character cannot convert value of type character to expected argument type string.
Okay.
That's in on line 65. So yeah, this concatenation isn't working. I think we need to have a sort of mutable. Okay, yeah, that should probably work.
And here as well.
Mm-hmm.
I was pressing buttons while you were pressing it. Yay, we solved that one. Cannot use mutating number on immutable value. That is... What? Change let to var to make it mutable. The set
Well-
of... Okay, I will do that.
Okay, yeah.
If you want to do that. But I don't really get it because apparently it's not the same as in JavaScript. I'm not mutating the reference to the set. I am mutating the set elements. And yet I have to declare
Yeah,
it as a
but it's-
variable.
But is JavaScript right or is Swift right? Because
Well,
it's kind of misleading that you can have like a const array, but then like the array is changing all the time.
well, you have a
just the
constant
reference.
reference to a mutable array. An immutable
Yes.
array is coming, hopefully, in
Yeah.
the future in JavaScript. There is a proposal for, it's not really a mutable array, it's an immutable, essentially it's like a tuple, which is an immutable array. But yeah, I prefer what I'm used to. What a surprise. All right,
Okay,
we got a
so-
number. 4, 6, 7. And is that a good number? That is not a good number. Oh, it is a good number. 467835. We got this. We got
Nice.
this.
All right. Let's do. Do you want to do your puzzle input so we can?
Yes, I am doing it now. And we got a huge number here. Are we gonna, in Swift, are we gonna run into problems with number sizes? Not in this problem, because the output seems small enough, but is there a thing like in C# like we had yesterday?
I honestly don't know, but I've never run into issues with int.
That's the right answer! Woohoo!
Woohoo! Well done.
Good job, everyone! Congratulations! Now, can we see the tree? Oh, look at that!
Very nice.
Cute.
How long did that take? An hour and a half. Oof. Should it? Okay, I've learnt my lesson. I know to trust your gut.
Yeah, in the end, the approach that we implemented pretty much amounts to what I was describing, right? Of course, previously we would have to do it for all symbols instead of just the multiplication sign, but we ended up doing the set, the whole thing, the duplication, the whole thing.
Yeah. I might implement the breadth first search version of it
Well, wait a second.
to see.
Isn't that what we did? We start at the star and then we expand?
Yes, it is.
Or do you mean something else when you say breadth first search?
No, that is pretty. It's pretty much it, actually. Or what I mean is just more like the original. I guess we're starting from the star and then doing breadth first search out, which makes sense.
Yeah.
But I wonder if it makes sense to do it from numbers and then like keep exploring the chain and keeping a global set of coordinates that we keep. I mean, I don't know that it might be less code because we don't have to go like left and right and stuff because we're always iterating from left to right. We'll always like incorporate numbers. Well, actually, no, that's not true because you always need to. No, yeah, it's a bit trickier, isn't it? Anyway, let's look at some of the other implementations.
Yes, let's. So here is the subreddit. And we are sorting by best. And 33 minutes ago, or 5 hours ago. So this was a person in the leaderboards because, right? 5 hours ago, it was about the time when the puzzle was released. It turns out that the solutions to both parts are nearly identical. Well...
That is just amazingly simple. It doesn't make any sense.
Again, the default ticked. We saw that yesterday. And it's reading the file. It is parsing all the special elements. Then it is finding the whole number. It is collecting the coordinates. Oh no, it's just iterating over the coordinates. Then, what is this? Oh, it's here. Oh, that's cute. What is that?
So hold on. What's going on here? Okay, so they actually get the integers by using regex again, which is pretty cool. That looks like a bitwise operator.
It looks like a bitwise operator. That's why I'm surprised.
Yeah.
Because it's a tuple, so it's using a bitwise, or actually, yes, the edge is not a tuple. It's a set.
Oh, it's a union. It's a union. operator, I guess.
So this operator has been overloaded. I'm alright with that.
Yeah.
And then what is M?
M is... Where is M even defined? Oh, it's maths. The prod
Yeah.
is... Product is just like... It's the product of all of the entries.
Well, but on a high level, the approach that they are using is to collect the parts. So it is what we ended up doing, right? It is collecting all the values that are around a symbol.
Yeah.
Parts
Hold on, I'm
is
just trying to...
part is it is a set, or I guess a dict, in which the keys are this
Union.
the symbols, and the elements are lists of values neighboring the symbols. So yeah, this is written in a clever way, but it is essentially the same idea of find the symbol, find all the neighbors that are numbers, and if they have the right length and so on, multiply them.
I'm just a bit confused by this edge equals, because what it's doing is finding in the row all the numbers, right?
Mm-hmm.
And then it's going through, it's creating a set out of the rows and columns of that number. So the columns are just the start and the end. So it's collecting all the numbers in that. It's interesting that he's calling it edge, like as in there's a node and then there's edges. And like each number is an edge somehow. But yeah, so it's collecting all the numbers in a row and then finding all the special characters.
Yeah, I don't know, but what I do know is that this approach is in principle similar to ours. So I want to see wacky things.
Okay.
Wow, this makes two assumptions that ended up being true for the input. No number touches more than one symbol. We got that. No non-star symbol touches exactly two numbers. We didn't see that happening. But it is true. When you see a slash or a minus or how do you even call this these days? Do you call it a hash sign?
Yeah, hash.
An edge. Not only they are never close to two numbers, but they are never alone as well. They are always close to exactly one number. Or no, I'm wrong. Oh yeah, I'm right. I just had to scroll up. Anyway, cute.
So that's how he filters them all out, which are only of a set of one.
Yeah, I was looking at this and I was like, how is the person not checking that you have the right symbol? You don't have to check that you have the right symbol.
Yeah.
You can go by count. Vim keystrokes. Now we are talking. Load your puzzle input, type this in, or copy and paste for the long blah, and your answer will appear. Okay, let's dive into this. What's happening? Control V is to get into block mode selection. Then capital G gets you to the start of the file. Then you go into insert mode in the beginning of the line. Then you put a dot and then you escape back. So you're adding a dot to the beginning of the line. Why? Then, oh geez, this is complicated. And then you go to, what is V? I forget.
Isn't it paste?
The
actually,
Y
I don't
is
know.
gonna yank. The P is gonna paste.
Oh, yeah.
So I forget what the V does. I know that it's gonna yank to the end of the line and then paste and then yank again. Wow.
So wait, Shift Y is different.
Well, you know what I have on my computer? I have
Vim.
Vim. It comes with the operating system. So how about I just do as they say and load your puzzle input for day 3. And then let's go step by step and understand at least this first line we should be able to understand. It doesn't seem terribly difficult, right? So I suppose that you want to be in the beginning of the file. Let's do that. And then Control V gets me into visual block mode, which for those of you who don't know Vim, you're just getting like column selection, right?
Oh.
Anyhow, so we got into visual block and then capital G. Oh, that goes to the end of the file, not the beginning, as I said. And then capital I gets us into insert mode, but in the beginning of the line. So it didn't really matter what my cursor was when I started. No, it mattered because I needed to be on the first line. Anyway, and then dot. I wonder why they wanted to add a dot to the beginning of every line. How is that relevant? Because then you don't have to worry about going over the edge of the board.
Oh, that's nice.
We could have done that with our solution as well, just to keep the code slightly simpler. But anyway, and then it's saying G, V. It gets into visual block again, and it goes to the end of the file again. Then Y. So block of 10 lines have been yanked, which is Vim speak for copy. Then go to the end of the line with the $, and capital or lowercase p is going to paste that column. So now we have the dots at the end as well. So this is just formatting the input for the edges of the board. Then I am at the capital Y, capital P. So that copies the line. This way, we have a new line at the top, and I bet that it's going to do a search and replace for the rest of the line to replace the line with dots to have the sentinels at the top. So it's capital V for visual line, replace with dot, that's what the R does, then yank with capital Y, go to the end of the file with capital G, and paste again. Amazing.
All right, now do that in super speed.
And then this is gonna be search and replace digits with a function that I don't know, but it's probably number to character. So it's gonna take a submatch. Okay, so search and replace, this is the regular expression. Then submatch 0, who knows why, and then character to number. So it's gonna take each of these characters and transform into their ASCII numbers, probably. Add 49, so it's probably because 50 is one. What is 50 in the ASCII table? Because lowercase letters start at 60. Oh, but that's in hex. Oh, I don't know. And then do this whole replace globally. So let's see. Oh, I had the column twice. Oh, no. Control C. No. Comment to that. Undo. Okay. I will copy just this part. Okay. So we replaced the numbers with the letters that correspond to the ASCII representation of the numbers themselves. Why? Why though? Well, I guess we are about to see because we're going to run the next line. Then QA, we are about to record a macro of keystrokes. You can see that we are recording here, and we are recording into the register A. Then QQA, we are now doing a recursive macro. And then I suppose I have to type all of this by hand. So we are starting a search with a regular expression that I'm searching for anything that isn't a dot or an A to Z. And of course, I'm not running this. I am just setting up the macro, I guess. Then replace with dots. And then I don't know why we are moving this way, but we are moving to the top left. And then Control V to get us back into Visual Block. Then go down, go right, and then undo. And then look at register A, and then quit, and then, okay, we did a recursive macro that does something, and I'm gonna run it now. What the heck has happened? Well, it replaced a bunch of things with dots.
Yeah.
What is left in these places? 114 is left. And this 58 is left. Oh, look at that. There was a number that didn't have any symbols adjacent to it. What the heck?
So it's going to invert everything now and recover what we needed?
What the heck? Well, anyway, let's continue with this. But I think it lost some of the information. So I think at some point it will need to undo. But anyway.
Yeah.
So right now I think it just selected all the numbers that don't have any symbols adjacent to them.
Is somebody trolling us?
No, it's finding all the numbers that don't have any symbols adjacent to them. We are about to put a sentinel here, and like a character that we will no longer replace. And then we're gonna put a sentinel here. We are gonna undo to get our numbers back, and then we are just gonna add them up. We have just done the hard part of filtering the right numbers. But anyway, I don't want to get lost here on my inputs. So I'm at this point. Let's run. This is a search and replace using an escape character that I don't know. And I don't really understand this regular expression at all. But I see an undo at the end here. So let's do that. I will V. That gets me into visual mode. I'm going to insert. I'm going to P. What is P doing in this context? I'm not even sure. And then U. And lines have changed. I think I messed something up. It doesn't look right.
You might have moved your cursor to the wrong position.
Maybe. Yeah, at this point it's pretty much over, I guess. And then C and Control R and equals and Control R and -0 and enter and escape. But no, yeah, I messed something up in the middle. That's too bad. At least I know how to quit Vim. What do they have to say about this? The main at A, that's a macro. What's the dagger? What do you mean it doesn't make sense for a bunch of keystrokes to have such a program-centric concept as a main loop? Oh no. They are replacing the numbers with letters because the point is that it's going to select all the neighbors and capitalize them. So if you see a capital letter, you know that it is adjacent to a symbol.
What? I didn't understand that.
Well, our point is we want to mark numbers that are adjacent to symbols because we want to add them up. This is part one. And the way that he does that is by replacing every every digit with a letter. Because then you can use lowercase letters to mean I'm not adjacent to a symbol, and uppercase letters to signify I am adjacent to a symbol. So you can, in Vim, do a block selection for all the neighbors and then use a command to capitalize. Which I suppose is the part that I messed up because I didn't set up the macro right. It didn't capitalize.
Yeah. But how does he like expand the numbers so that it like, you know, converts? I guess he finds if there are any words which are capitalized at all, capitalize them entirely. Is like some secondary step he does. It's a pretty cool idea, actually.
Yeah, I don't want to continue going down the rabbit hole here, but it was interesting to use the expansion of the board to make the problem slightly easier. And I like the idea of using the letters to mark that they are neighbors of symbols. That's clever.
Yeah, definitely. And I wonder if we could have used that idea in our program as well. Would have been interesting.
Yeah, and in a way, again, they are kind of finding the symbols and then finding the adjacent numbers. So in spirit, it's the same solution as ours and the first solution as well. Let's see this person who wrote in Python. Yeah, again, the default digit, we kind of have seen variations on this. Now, this is just, it's going to be every day, right?
Yeah, APL, my God. Oh, TypeScript.
Oh, almost entirely using a singular regular expression? I wanna see that.
Did they really need it to be public static for TypeScript?
Okay.
Wow.
Let's see what we have here. Yeah, first of all, why the object-oriented approach, right?
Yeah.
Ooh, that's the kind of juicy thing that I'm looking for. So what's happening here? We have a match with a big regular expression and then a reduce. What is this gonna do? Why 2 plus signs?
We could chuck the.
I know why. I know why 2 plus signs. A plus sign like that is gonna be interpreted as a unary operator, and then it's gonna convert into a number. So that's how you go from strings of digits into numbers. Okay, and you start reducing with 0. So this is just doing the summation, and the regular expression is doing the filtering for the relevant numbers. So all there is left to do is understand this line. Oh, this line is printing the sum. Okay, we're done. No, let's see. What have we here? Well, it's going to be a global match, and it's going to interpret dots are going to match new lines as well.
It might be helpful to put this regex into like one of those regex formatters, but maybe we can probably get.
Do you have a recommendation for one? I don't know these tools very well.
I've used a few in the past. think is it regex 101 or regexer? Oh yeah, regexer.com. Looks quite nice. Might help, might not. Can you paste? Yeah. Yeah, maybe get rid of the menu. So
Yeah, there is no way of getting rid of this. Well, there is. I am the owner of this browser and this computer. I can find a way. The space remains. Come on. Come on. There.
yeah, just get rid of the menu on the left so we have more. The sidebar, there's a X there. That should work.
Okay. So we start with some pipes. So there's going to be some alternation. This is one chunk, this is another chunk, and that's a chunk, and that's a chunk.
Okay.
Looking good. Then the first chunk is going to capture any number of digits. It's going to do a look behind to get non-digits, dots, new lines. Then it's gonna match everything for 140 to 142 characters. So I suppose that is the length of this line. And then it's gonna force the
Wait, hold on.
the capturing of a digit. You know what I want to do? I take it back. I kind of want the test. So there and this and that. Wow, look at that. Look at that.
Maybe the sample input?
No, because this hard-coded the length of the line.
Oh, yeah, you're right.
So I wish that this didn't wrap, but it does, and I don't know of a way of changing that.
There's probably CSS for that, but yeah,
there is CSS for that. Do you wanna go there?
Yeah, all right.
It's using CodeMirror, so no, I'm not gonna go there.
Okay, yeah.
But I am happy that we can at least see the numbers that are highlighted like that.
You could zoom out loads, I suppose, but yeah, we need the zoom for the.
Well, you can barely read this now, but at least we can confirm that it's doing the right thing. Numbers that are not adjacent to symbol. Oh, wait a second. This is adjacent to a symbol. And so are these. Oh, because I didn't put the flag. That's why. There. Okay, I can see that this works. Let's see each part, because they are at the top level, so we can ignore everything else and look at the parts individually. So this first part is capturing the numbers.
You need the flag?
No, the flag is there now.
Okay.
And this is capturing some numbers that we don't even want. Oh, we do want this, yes.
It's doing surprisingly well. Oh, is it just like capturing like based on like above and below? Like is each segment for like the like
it is using this flag so that the new lines are gonna be consumed by this dot. So when you do this dot 140 to 142, what you're doing is skip. For instance, let's look at this 475. You find the digits 4, 7, and 5 using this. or maybe even using that. I don't know, whatever. But the point is, dot 140 to 142 means dot means match anything, including new lines. 140 will get you down to the next line. And then you match some. Okay, so this part is matching something that is not a number, a dot, or a new line. So it's, for instance, matching, let's say, this star. So this first part matches this star. Then skip 140 to 142 characters, so going down to the 3 down neighbors. That's why 140 up to 142 inclusive. So that will get you the 3 downstairs neighbors. And then match the numbers. So that's the 470.
Wow.
How about that? So with this regular expression, you have matched all the numbers that are downstairs neighbors of the symbol on the next line. Then with the next alternative, which is this, you're probably going to do the same, but for the upstairs neighbors, right? We are going to do some skips, find a symbol, and then digits. Yeah, this parenthesis here. So this is find a number that I care about, then skip a bunch, and then find a symbol. Skip a bunch, find a symbol.
This is also positive look ahead, wasn't it? Negative look ahead before?
This is positive.
But before it was negative?
Positive. Yeah, both were positive.
Oh, positive look behind, sorry.
Positive look behind, yes. But yeah,
So
the one that we are looking at now is going to find the upstairs neighbors of all the symbols using similar logic, skipping around, finding symbols, and capturing the digits. Then for the third, well, that's easy. We can even see it here. That's easy. It's just find a character that we care about, like the ampersand, and then get all the digits to the right of it. And this is going to do the same to the left. So find a character that we care about, for instance, this star here, and then look at the digits to the left of it. So once you do all that, you get just the numbers.
Wow.
I love this. Do you know how to detect if a number is prime using a regular expression? Have you heard of this before?
No, I have not.
Do you want to know about it?
Yeah, go on.
I don't need this slide for this one. So the trick goes like this. First of all, you encode your number in unary representation. So if this is decimal representation and this is binary representation, then unary representation is, for instance, the number 5 is 1, 2, 3, 4, 5. And the number 7 is this. And the number 0 is that. Okay? So let's get a number that is not prime. So, for instance, the number 8. Did I get it right? This is 4. No, I got it wrong. Like that.
Yeah.
So here's how you do it. You will first do a named capture for, I'm going to call this a factor. And you find the number 1 at least twice. Like so. At least twice because 2 is the lowest prime number.
Right.
Then you want to have, so you found one of the factors. You want to have the factor at least twice. So you're going to do a back reference to the factor.
Oh.
A back reference like so to the factor. And
Is that a back reference? I haven't seen that.
yeah, a back reference is whatever you matched here, you gave that the name factor. Now I want you to match the exact same thing here. So it's not the case that it's going to rerun the regular expression. No. It ran the regular expression and it found, in this case, a bunch of ones, but it found like, suppose that this regular expression was either David or Leandro. If it found David, this back reference needs to be David. It's not Leandro or David again. No. It matched David. Now it needs to match exactly David again.
Mm-hmm.
And I suppose it's always important in these wacky things to anchor to beginning and end of line. And you also want the factor to appear at least once.
Mm-hmm.
I think that is all there is to it. I may be missing something, but let's check. So 2 is not matching. 4 is matching. So yeah, it's right. Number 1 is not prime. Number 2, it is. Number 1 is not prime, so we should have a special case for the number 1. But let's look at the interesting numbers. 2 is prime, it's not matched. 3 is prime, it's not matched. 4 is composite, it's matched. 5 is prime, it is not matched. 6 is composite, it is matched. 7 is prime, not matched. 8, composite, matched. 9, composite, matched. 10, composite, matched. 11, not matched. There you go. That's the regular expression. I did it.
Wow.
Isn't this crazy?
Wait, how does this work?
You are decomposing the number into its factors. So first, you are going from the beginning of the line and you are finding a factor. How are you finding the right factor? You may be thinking, well, it's because the regular expression engine will have to satisfy this later part. But for the time, just believe that the regular expression engine will find the one prime factor. Then it will have to find that same prime factor again. So if you found the number 2, it will have to find that number 2 again, exactly the number 2 again. And it will have to find that yet again. So
show us a match, for example.
I will do the number 4 because that's relatively straightforward. It's the first match, right? It's the number 4. So in this case, this part is going to be 2 number 1s.
Yeah.
Then you're saying that, first of all, it matched, but it also gave it a name. And then you're doing a back reference. So now we are looking for the number 2 again.
Mm-hmm.
And it needs to appear at least once. So at least once you want to see the number 2 again. And you do see it here. So this plus isn't really doing anything on this case. It still matches. But it's necessary for the bigger cases.
Yeah, so what about one where it's like... Wait, so all non-prime, all primes are not matched.
Yeah, the thing is that it's finding the composites, so you would need to negate this.
Yeah.
If you wish to find the primes.
Yeah. Wow, my head's gonna explode. This is crazy.
Yeah, and here the same story, right? For the number 6, which is the next composite after the number 4, it is this first part is matching 3, and then the second part is saying, I want to see my 3 again. So in this case, it's 3 times 2, right?
But why doesn't the factor match 2 and then match it 3 times?
Oh yeah, that's right. It also does that. In fact, it's going to do that first. You are right. So
does that and then does 3.
Yeah, there are 2 ways to match this, and because we are doing this from left to right, it's actually going to do the thing that you mentioned. So it's going to find the 2 here, and then it's going to find this same factor 2 more times. So it's going to find this, and it's going to find that.
Oh, this makes a lot of sense, actually. Now I get it.
So this plus
Because if you
is
don't
essentially
have-
one of the factors, right? And this is the other factor.
That's so elegant. I love it.
Yeah, and
That's crazy.
yeah, there was something else that I was going to say about this, but I forgot. Anyway, we have been here for 2 hours, and I guess it's time for us to say our thank yous and goodbyes and schedule the next one. So when are you available?
Yeah.
Tomorrow?
I think I could do the same time.
Unfortunately, I cannot because I will be teaching starting tomorrow. So I will be unavailable from 9 to 6 at least.
Okay.
Could
you be available at exactly 6, or is that going to be like annoying? I mean, we could do it later as well, like say 10 or something. But
10 is good for me. 10 is good for me.
let's do 10 then.
Okay, so it's gonna be tomorrow at 10, but 10 p.m. this time.
Yeah, 10 p.m.
So keeping the time, just changing one letter. We are optimizing things here. So I will say thank you to Nod Was One and John and Bo and Jack and Tail for joining us on the chat. It's a delight to have you. And thank you again, David, for coming up with the idea for this project. And I'll see you again tomorrow at 10 for more of this.
See you tomorrow.
Have a good one. Bye.
Bye-bye.
Thank you for watching the stream, you know how great it has been. Or maybe it sucked, and I am glad that you stuck with me. And soon we'll all will be back together for some more coding or talking or chilling. The next time I'll be streaming.